Okay, so, hi guys. Well, our topic for our module in AC1, analog aircraft instruments, is remote sensing and indications. So, in remote sensing and indication, it is open, practical, or impossible to utilize the direct reading gauges for information needed to be conveyed in the cockpit. So, paglagay ng mga sensors at the most suitable locations on the airframe or engines and transmitting the collected data electrically through the wires to display in the cockpit is widely used method of remote sensing and indicating sa aircraft. So, sa lahat ng mga remote sensing instrument system, nagkukonsist sila simply ng sensing and transmitter unit and the cockpit indicator. Na usually, syempre, sa pinag-usapan natin sa remote sensing, connected sila each other by wires. So for flight instruments, yung ADC and the pickup devices, katulad ng Tito tube, static vents, etc., comprise the sensing and transmitter unit. So many aircraft collect sense data in the dedicated engine and airframe computers. So yung mga information is napoprocess. So an output section of the computer then transmit it electrically or digitally to the cockpit for display. So yung remote sensing instrument system operate with highly reliability and accuracy, and they are powered by the aircraft electrical system. So sa mga small electric motors sa loob ng instrument housing, ginagamit yung position pointers instead of direct operating mechanical linkages. Nakaka-receive sila ng electric current dun sa may output section ng ADC or other components. Nakaka-receive din sila ng input from sensing transmitters o kaya transducers that are remotely located in the aircraft. So by varying the electric signals, yung mga motors are tuned to the precise location needed to reflect the correct indication. So direct electric transmission of information from different types of sensors is accomplished with few reliable and relatively simple techniques. So hindi lahat ng digital cockpit display of receive all of their information from the digital air data computer and other computers by digital databases and do not use electric motors. So yung mga data packages transmitted via the bus contain the instruction on how to illuminate dun sa may display screen. So, meron tayo ito, yung mga synchro type remote indicating instruments. So, sinasabi nga dito, a synchro system is electric system used for transmitting information from one point to another. So, the word synchro is shortened from the word synchronous and refers any of one of a number of similar operating two-unit electrical systems capable of measuring, transmitting, and indicating a certain parameter on the aircraft. So the most common types ng synchro systems are the autosyn, cellsyn, and magnesyn synchro system. So, ulitin lang natin itong synchronous refers to any numbers of similar operating two-unit electrical system and capable of measuring, transmitting, and indicating a certain parameter on aircraft. So, yung mga almost yung mga position indicating instruments are designed around the synchro system such as yung mga flap position indicator. Yung fluid pressure indicators also commonly use a synchro system. Synchro systems are used as remote position indicators for landing gear, autopilot system, radar, and many other remote indicating applications. Itong mga system na to are similar in construction and all operate by exploiting the consistent relationship between electricity and magnetism. So the fact that electricity can be used to create magnetic field that have definite direction and that magnetic field can uh, interact with magnets and other electromagnetic field is the basis of their operation. So kung makikita nyo dito sa may DC cell-syn system, ayan, kung magbe-base kayo sa image, sa aircraft with direct current electrical system, kaya nga siya tinawag na DC, yung DC cell-syn system is widely used. So yung cell-syn system consists of a transmitter. So kung titignan nyo dyan, yan, merong transmitter and merong indicator and then ito yung mga connecting wires. Yan, yung mga connecting wires. So the transmitter consists of a circular resistance, winding, and rotatable contact arm. So yan, si contact arm. Itong nakikita nyo is nagro-rotate yan. So the rotatable contact arms turns on the shaft in the center of the resistance winding. So yung two ends of the arm are brushes and always touches the winding on the opposite side. Yan, ito yung dulo. Yan, umiikot to. So, on position, indicating system, yung shaft to which the contact arm is fastened protrudes through the end of the transmitter housing and attached to the unit whose position is transmitted, katulad ng flaps or landing gears. So, yung transmitter is often connected sa mga moving unit through a mechanical linkages. As the unit moves, it causes the transmitter shaft to turn. So, katulad nitong nakikita nyo sa lower image, yan, ito yung nakikita nyo dito, rotor shaft. Ito yung rotor shaft niyan, for example. And then, yung mga brushes, ito yung heading example sa brushes. So, itong dulo ng brushes, nagro-rotate yan dun sa resistance winding. Okay? And then, nagge-generate yan ng electricity. So, once na nagge-generate or nagkakaroon siya ng electromagnetism, which is nagtra-transmit dito, gumagalaw ito. Okay? In-help niya. So, itong part na to is nagiging magnet. So, kaya siya nagro-rotate. So, ulitin natin, yung the arm is turned so that the voltage applied through the brushes to any 2 points around the circumference of the resistance winding. So, yung rotor shaft dun sa may DC cell-syn system, measuring other kinds of data, operates the same way but may not protrude outside of the housing. So, yung sensing device which imparts rotary motion to the shaft could be located inside the transmitter house. So, syempre, kung titignan nyo ulit yung figure, the resistance winding of the transmitter is top off in 3 fixed places. Yan. 3 fixed places. Ito din. Kahit yung dito, same. Usually 120 degrees apart. So, yung the top, itong mga top na to distributes current through the toroidal windings of the indicator motor. Yan. Same sila dito. Itong B, dito, and dito. So, kaya pag yung current flow, uh, when the current flow through these windings, a magnetic field is created. Katulad ng sinabi ko kanina, pag umikot to, nagkakaroon na siya ng electromagnetism or sinatawag natin magnetic field and nakakreate na yung galing sa winding. So, katulad ng mga magnetic fields, a definite north and south direction to the field exists. Yung mga transmitter sa rotor shaft is turned, so the voltage supplying contact arms move because it contacts the transmitter resistance winding in different positions. So the resistance between the supply arm and the various top-off changes. So itong nagko-cause ng voltage flowing through the top-off to change as the resistance of the section of the winding become longer or shorter. Kaya yung result, nagva-vary dun sa may current via the top-off to the three windings in the indicator motor. Ay, sorry. Wait. So, yung resultant na nakikreate dun sa may magnetic field by the current flowing through the indicator coils changes as each receive varied current from the top. Kaya yung direction of magnetic field also changes. Yung dito. So, nagkakaroon na yan. Nagkakaroon na yan ng magnetic field. So, the direction of the magnetic field across the indicating element corresponds in the position to the moving arm in the transmitter. So a permanent magnet is attached to the center rotor shaft in the indicator as is the indicator pointer. So yung magnet nag-a-align itself with the direction of the magnetic field and the pointer as well. Okay, kaya din siya may permanent magnet and pointer kasi mag-a-align yan kung saan merong malakas yung magnetic field. So, kaya nagro-rotate yan. Kaya example, makikita nyo dito, 0, 25, yan, 50. So, example lang yan sa instrument scale. Kaya whenever the magnetic field changes, the direction of the permanent magnet and the pointer realign with the new position of the field. So, the position of the aircraft device is indicated. So, katulad sa mga landing gear contain mechanical devices that lock the gear up called, meron tayong tinatawag na up lock or down na tinatawag nating down lock. Yan. And nakikita nyo din dyan sa images, meron siyang up or down. And up or down. So, katulad nung kanina sa pinag-usapan natin, when the DC sensing system is used to indicate the position of the landing gear, si indicator can also show that the up lock or the down lock is engaged. So, this is done again by varying the current flowing through the indicator coils. So, switches located on the actual locking device closed when the lock engaged. So, yung current from the sensing system described natin kanina flow through the switch and small additional current, additional circuit. Okay? So, example lang natin. Dito. Balik tayo. Okay? So, example, ito yung brushes mo. Yan. Okay? So, sa indicating ng ating landing gear, okay, magro-rotate itong brushes kasama nitong dalawa. Pag nag-rotate yan, okay, may mag-transmit dito and transmit dito. So, itong pointer na to, habang nag-rotate to, tinutulak niya si pointer papunta dito sa 25 degrees. Okay, ganun yung nangyayari. Kaya dun sa may mismong makikita nyo, pag example sa landing gear, pag down lock na siya, yan, example sa 50 degrees, nakababa na mismo yung landing gear. Meron dito sa sinasabi natin kanina, may additional kang circuit para doon iilaw kung naka-retract na ba si landing gear. Okay, kaya kung mapapansin nyo dito, sa image na yan, nag-illuminate siya. Okay. So, example, pag landing gear indicator, button illuminated, green, related gear down, and lock. Ganun yung nangyayari. So, the result is a change in the current flow through one of the indicator motor coils. So, this in turn changes the magnetic field around the coil. So, therefore, yung combined magnetic field created by all three motor coils is also affected, causing a shift in a direction of indicator's magnetic field. So, yung permanent magnet and the pointer align with the new direction and shift to the lock position on the indicator dial. Yan. Ito na yung example na sinasabi natin. Okay? So, dito, pinapakita yung simplified diagram ng lock switch in a 3-wire cell scene system and an indicator coil. Katulad ng sinasabi ko kanina, itong rotatable contact na to, once na umikot to, yan. Once na umikot to, example lang natin, umikot to pababa or ano, clockwise motion. Okay. Magsisend yan ng electromagnetic field and ito, magsisend siya na bumababa yung pointer. So, once na na-receive na bumaba yung pointer, ikot na yan dito and lalabas pa din yan dito na naka-downlock na si mismong landing gear. So, ganun din. Vice versa. Pag nag-counterclockwise naman, okay, nagkakaroon ng magnetic field, tutulak naman or mapupull naman siya at itong pointer mag-up and magsisense naman siya dito. Ano yung nangyayari? Sa labas na nakataas na si landing gear. So, dito naman tayo kay AC synchro system. So, aircraft with alternating current, electrical power system, make use of autosyn or magnesin synchro remote indicating system. So, katulad lang din siya ng DC cell sync system, pero gumagamit lang sila ng AC. Kaya yung pinaka-power nila is alternating current. So, they make use of electric induction rather than resistant current flows defined by the rotor brushes. So, yung magnesin system use permanent magnet rotors. Next slide. Yan. So, yung magnesin system, gumagamit siya ng permanent magnet rotors such nakikita nyo in the DC cell sync system. So, the transmitter is larger than the indicator. Okay. Ganun din. Pwedeng ganito. Is larger than the indicator. indicator magnet, but the electromagnetic response of the indicator, rotor, magnet, and pointer remains the same. So, ang nangyayari naman dyan, yan, it aligns with magnetic field set up by the coils and adopting the same angle of deflection as the transmitter rotor. Okay? So, madali lang siya intindihin din. Once na umikot yung magnet dito, or let's say yung rotor na naka-attach dito, okay, same yung nangyayari sa transmitter and indicating or indicator. Yan nangyayari. Same, AC. So, yung mga auto-syn system are further distinguished by the fact that the transmitter and indicator rotors use electromagnets rather than permanent magnets. So, katulad ng permanent magnet, an electromagnet aligns with the direction of the magnetic field created by the current flowing through the stator coils in the indicator. So, yung indicator pointer position mirrors the transmitter rotor position. Yan. Same lang din. Okay? Pag gumalaw si transmitter, same kay indicator. So, AC synchro system are wired differently than DC system. So, they are varying current flows through the transmitter and indicator, stator coils, and induce as the AC cycle through the zero and the rotor magnetic field flux uh, is allowed to flow. So, the important characteristics ng synchro system is maintained by both the autosyn and magnesyn systems. So, the position of the transmitter rotor is mirrored by the rotor in the indicator. So, these systems are used in many of the same application as the DC systems. So, since they are usually part of instrumentation for high-performance aircraft, yung adaptation of autosyn and magnesyn synchro systems are frequently used in directional indication and in autopilot system. So, kung pupunta tayo sa remote indicating fuel and oil pressure gauge, yung fuel and oil pressure indications can be conveniently obtained through the use of synchro system. Kasi, katulad ng sinabi ko before, if merong nakakatanda sa inyo, syempre, bawal ka naman maglagay ng fuel line and oil line into the cabin to the direct reading gauges. Syempre, hindi desirable yun na nagdadala ka ng fuel or oil sa may cabin. So, nag-i-increase yung fire in the cabin, and the additional weight of the lines are two primary deterrents. Kaya by locating the transmitter of a synchro system remotely, fluid pressure can be directed into it without a long tubing run inside the transmitter. The motion of the pressure bellows can be geared to the transmitter rotor in such a way as to make the rotor turn. Okay? So, kung intindihin nyo lang yung image nito, ito ay meron siyang wire. So, meron silang transmitter na binabasa doon sa may example, engine oil or fuel para yung transmitter rotor turns proportional to the pressure sense, which varies the voltage set up in the resistor windings of the synchro stator. So yung mga voltage are transmitted to the indicator coils that develops the magnetic field that position the pointer. Siyempre, pag ikaw ay naman ay naka-twin engine aircraft, Yung synchro mechanism for each engine can be used to drive separate pointers on the same indicator by placing the coils one behind the other. So each pointer responds with the magnetic alignment in its own motor's magnetic field while sharing the same gauge housing. Okay, so hindi ko pala siya nasama. So, yung image. So, pinapakita lang dito, example, ito yung indicator nyo ng oil or fuel. So, meron lang siyang pointer na isa at meron pa siyang pointer na isa. Labeling the pointer engine 1 or 2 removes any doubt about which indicator pointer is being observed. So, similar principle is employed in the indicator that has side-by-side indication for different parameters such as oil pressure and fuel pressure in the same indicator housing. So each parameter has its own synchromotor for positioning its point. So ulitin natin na, kung ikaw ay tumitingin ng parameters ng aircraft, meron silang synchromotors. So aircraft with digital instrumentation makes use of pressure-sensitive solid-state devices, sensors that output the digital signals for collection and processing by dedicated engine and airframe computers. So other may retain their analog sensors but may forward this information through an analog to digital converter unit from which the appropriate computer can obtain digital information to process and illuminate the digital display. So many more instruments utilize the synchro remote indicating system described in this section or similar synchro. So sometimes simple, more suitable, or less expensive technologies are also employed. So, yeah. So dito naman tayo sa mechanical movement indicators. So there are many instruments on the aircraft that indicates the mechanical motion of a component or even that the aircraft itself. Yung iba, nag-utilize ng synchro remote sensing and indicating systems na katulad nung nabanggit natin before. And yung iba is for capturing and displaying mechanical movement information are also used. So, yung iba ay unique mechanical motion indicators and groups instrument by function. So, lahat ng nagbibigay ng value, fit ng value to the pilot on the conditions of the aircraft in flight. So, meron tayong tachometers or tinatawag na TAC, TACH. Is an instrument that indicate the speed of the crankshaft of reciprocating engine. So, it can be direct or remote sensing indicating instrument. So, yung dial which is calibrated into revolutions per minute or RPM. Sa mga reciprocating engines, yung mga TAC is used to monitor the engine power and ensure the engine is operated within the certified limits. So may Yun din, may limitation din. So, hindi laging puro mabilis yung ikot ng makina. Lagi din tinitignan. So, sa mga gas turbine engines also have tachometers. So, they are used to monitor the speed of the compressor section of the engine. So, our turbine engine tachometers are calibrated in percentage of RPM with 100% corresponding to optimum turbine speed. So, ito yung nag-allow ng similar operating procedures despite the varied actual engine RPM of different engine. In addition to the engine tachometer, mga helicopter gumagamit ng tachometer to indicate the indicator main rotor shaft RPM. It should also be noted that sa lahat ng mga reciprocating engine tachometers also have a built-in numeric drums that are geared to the rotational mechanism inside. Kaya kung nakikita nyo here, yung sinasabi nating drum is ito. Yan. So, there are two types of tachometer system in widely used. Meron tayo syempre mechanical and electrical. So, sa mechanical tachometers, yan. Yung mechanical tachometers indicating systems are found sa mga small engine light aircraft in which a short distance exists between the engine and the instrument panel. Okay? So, kung mapapansin nyo, sinabi natin, short distance from the engine to the instrument panel. Katulad ng mga Cessna. Yan. So, they consist of indicator connected to the engine by a flexible drive shaft. Yan. So, kung nakikita nyo dito, flexible drive shaft yan. So, wire yan. Example from the engine papunta sa may instrument. Yan. Pero hindi naman sobrang flexible. Basta flexible lang siya. So, itong drive shaft na to is geared into the engine. So, pag yung the engine turns, pati yung shaft. So, the indicator contains a flyweight assembly. Kung nakikita nyo dyan, yung flyweight assembly coupled to a gear mechanism that drives a pointer. As the drive shaft rotates, centrifugal force acts on the flyweight and moves them to an angular position. So itong angular position varies with the RPM of the engine. So the amount of movement of the flyweight is transmitted through the gear mechanism to the pointer. So itong nakikita nyo to. So kung ganyan siya, hmm, hmm, hindi mawala. Okay, kung ganyan siya, nakikita nyo, ito, pag bumibili siya, is either umaangat yung flyweight or bumababa. So, the amount of movement of the flyweight is nagtatransmit dun sa may gear mechanism ng pointer. So, the pointer rotates to indicate this movement on the tachometer indicator, which is directly related to the RPM of the engine. So, a more common variation of this type of mechanical tachometer ay gumagamit ng magnetic drag cap. So, ito yung drag cap niyan. Yung mismong outer portion. Nakikita nyo. Yan. To the movement in the pointer in the indicator. Yan. So, as the drive shaft turns, it rotates permanent magnet in close tolerance aluminum cup. Ito. Yan yung rotating magnet. And, nagro-rotate siya dito sa may drag cap. So, as the magnet is rotated by the engine flex drive cable, its magnetic field cuts through the conductor surrounding it, creating eddy current in the aluminum cup. So yung current flow creates its own magnetic field which interacts with the rotating magnetic flux. So yung result, the cup tends to rotate and with it the indicating pointer, a calibrating restraining spring limits the cup rotation to the arc of motion of the pointer across the scale on the instrument face. Okay? So ito nakikita niyo yung spring na to, yan yung nagdi-limit para hindi naman umikot na umikot si pointer. So meron naman tayong tachometer, electric tachometer, sorry. Okay. Yan. So balik tayo. So dito sa electric tachometer, it is not practical to use a mechanical linkage between the engine and the RPM indicator sa aircraft. With the engine not mounted in the fuselage, just forward of the instrument panel. So greater accuracy with lower maintenance is achieved through the use of electric tachometer, which is yung nakikita nyo ngayon sa figure na yan. So a wide variety of electric tachometer system can be employed. Kaya yung mga manufacturers instructions should be consulted for the details of each specific tachometer system. So, yung popular electric tachometer system makes use of a small AC generator mount to a reciprocating engine gear case or the accessory drive section of the turbine engine. As the engine turns, so does the generator, which nakikita nyo. So, the frequency of the generator is directly proportional to the speed of the engine. Yan, nakikita nyo, yung tachometer generator sa image nyo, nakakabit yan dun sa may engine. Yeah, directly proportional kung gaano kabilis yung ikot ng engine, ganun din iikot si tachometer generator, which is nakalagay siya dito kay drive coupling. So, it is connected via wires to a synchronous motor in the indicator that mirrors the output. Yan, nakikita nyo, meron 3 wire dyan. Naka-wire na lang siya papunta dun sa may indicator. So, less maintenance, hindi pa nakakabigat sa aircraft. So, a drag cup or a drag disc link, kung nakikita nyo, yung drag cup dyan, is used to drive the indicator as in a mechanical tachometer. So, meron naman tayong 2 different types of generator units distinguished by their types of mounting system. So, yung mounting system, nakikita nyo, meron tayong pad type and screw type. So, yan yung kinakabit mismo dun sa may engine. So, same lang din. Sa dual tachometer consists of 2 tachometers indicator units housed in a single case. So, the indicator pointers show simultaneously 1 or 2 scales yung RPM ng 2 engine. So, a dual tachometer sa may helicopter often shows the RPM of the engine and the RPM sa may main rotor. So, a comparison of the voltage produced by the 2 tach generators of this type of helicopter indicator gives information concerning clutch slippage. Okay? So, syempre, clutch slippage yung pag hindi kabit, pagka sa car hindi kumakagat yung clutch. Nakikita nila doon. So, a third indication showing the slippage is sometimes included in the helicopter tachometer. Sa mga turbine engines, gumagamit ng tachometer probes. Yan, kung nakita nyo, may probes for the RPM indication rather than a tach generator system. So they nagpo-provide sila ng great advantage in that. So there are no moving parts. Okay, so hindi na siya nagigiskisan. So gumagamit lang sila ng probe. So they are sealed unit that mounted on the flange and naka-protrude dun sa may compressor section ng engine. So kung napapansin nyo itong probe na yan, kung example, yan yung engine, yan, may naka-protrude. So pag naka-protrude, may nakabaon doon mismo at tinitignan yung ikot ng gear wheel. So rotating gear wheel which move at the same speed as the engine compression shaft alters the magnetic flux density as it move past the pole pieces at close proximity. Kaya kung nakikita nyo dito, yan, meron siyang permanent magnet which is pag nagro-rotate si gear, nade-detect niya yung pag-ikot ng gear. So, this generate voltage signals into the coils inside the probe, and the amplitude of the electromagnetic field signals vary directly with the speed of the engine. So the tachometer probe output signals needs to be processed in remotely located module. So they must also be amplified to drive a servo motor type indicator in the cockpit. So they may also use an input for an automatic power control system for a flight data acquisition system. Now, pagpunta na tayo sa synchroscope. So, sinasabi sa synchroscope is an instrument that indicates whether two or more rotating devices such as engines are synchronized. So, since synchroscopes compare RPM, i-utilize nila yung output from the tachometer generators. So, the instrument consists of small electric motors that receive electric current from the generators of both engines. So, current from the faster running engine controls the direction in which the synchroscope motor rotates. And yung example ng synchroscope. So if both engines are operating at exactly same speed, the synchroscope motor does not operate. Okay? Tandaan nyo, si synchroscope pa. Kung same sila ng speed, hindi gagalaw si synchroscope kasi synchronized na sila. Pero if the engine operates faster than the other, yung tach generator signals cause the synchroscope motor to turn in a given direction. Should the speed of the other engine then become greater than of the first engine, so the signal from its tach generator causes the synchroscope motor to reverse itself and turn into opposite side. The pilot may adjustment to steady the pointer so it will not move. So dito, pinapakita lang na yung use ng synchroscope involve a designating one of the engine as the master engine. So the RPM of the other engine is always compared to the RPM of this master engine. So the dial phase of the synchroscope indicates slow and fast, representing that the other engine's RPM is relative to the master engine. And yun nga, magme-make na siya ng adjustments accordingly. So kung yung RPM niya ba, okay, is bibilisan niya or babagalan. So depende na yun. Now, meron naman tayong accelerometers. So, si accelerometers is an instrument that measures acceleration. It is used to monitor the force acting upon an airframe. So, si accelerometers are also used in inertial reference navigation system. So, the installation of accelerometers is usually limited to a high-performance aerobatic aircraft. So simple accelerometers are mechanical, direct reading instrument calibrating to indicate force in G's. Sorry, hindi ko nalibat. Yan. So, yung 1G is equal to 1 times the force of the gravity. So, the dial phase of accelerometer is scaled to show positive and negative forces. So, when an aircraft initiate a rapid climb, a positive G force intend to push one back into one seat. Initiating a rapid descent causes a force in opposite direction, resulting in a negative G force. Most accelerometers have 3 pointers. Yung isa, kung nakikita nyo dyan, is continuously indicating the acceleration force experience. Yun yung sa main pointer. The other two containing ratcheting device, the positive D pointer to follow the continuous pointer and stay at the location on the dial where the maximum positive force is indicated. And yung isa is for the negative G pointer. That's the same for the negative force experience. Both max force pointer can be reset with a knob on the instrument face. So, si accelerometers operates on the principle of inertia. A mass or weight inside is free to slide along a shaft in response to the slightest acceleration force. Kaya pag nagmaneuver, creates an accelerating force. So kung mapapansin nyo naman, isipin nyo na lang pag nagmaneuver si aircraft, bumibilis. The aircraft instrument move, but the inertia caused the weight to stay at the rest in space. As the shaft slide through the weight, the relative position of the weight on the shaft changes. So this position corresponds to the force experience. So forces can act upon an airframe along the three axes of flight. So single and multi-axis accelerometers are available, although most cockpit gauge are of the single axis type. So inertial reference navigation system makes the use of multi-axis accelerometers to continuously calculate the location of the aircraft in the three-dimensional plane. Add ko na lang din, there are electric and digital accelerometers exist. So solid state sensors are employed such as piezoelectric crystalline device. Sa mga instrument na to, when an accelerating force is applied, the amount of resistance, current flow, or capacitance changes in direct relationship to the size of the force. So microelectric signals integrate well with digital computers designed to process itong display ng information in the cockpit. Now, for our lesson 3, meron tayong stall warning device and angle of indicators. So, an angle of attack for AOA is the angle formed between the wing chord, center line, and the relative wind. Center line, and then yung relative wind. At a certain angle, yung airflow over the wing surface is insufficient to create enough lift to keep the aircraft flying, and stall occurs. An instrument that monitors the AOA allows the pilot to avoid such condition. So, simplest form ng AOA indicator is a store warning device that does not have a gauge located in the cockpit. So, gumagamit lang ng aural tone to warn of an impending stall due to increase in AOA, yung angle of attack. Yan yung isang example is yung read type warning device located behind is opening in the leading edge of the wings. So, pag si angle of attack nag-increase to the near point of the stall, low pressure, air flowing over the opening causes ay suction. Nagkakaroon ng suction, parang humihigop. And which audibly vibrates the reed. So, may horn doon sa loob ng aircraft at tutunog. So, kung nakikita nyo din yan, yan yung cavity has an open passage to precise point on the leading edge. Pakita natin. So, kung titignan nyo din dito, in flight, the air flows over and under a wing. So the point on the leading edge where the oncoming air diverge is known the point of stagnation. Point of stagnation. So si AOA of the wing increases, the point of stagnation moves down below the open passage that leads inside the wing to the reed. Example lang kung ito yung reed. Ganun din. Okay? Pilitin natin na pag yung angle of attack wings increase, ito, nakikita nyo dito. Yan. Ibig sabihin, yung, tumaas na yung wings. Nakapataas to. Okay? The point of stagnation moves down below the passage that leads into the wing to the reed. Ipapasok doon sa may reed. Ipapasok dito. Example, yan yung reed. Air flowing over the curved leading edge speed up causes a low pressure. So this causes air to be sucked out of inside of the wing through the passage. So the reed vibrates. And yun nga, nagme-make siya ng sound. Same din yan dito sa ganitong klaseng stall warning switch or device. Meron din siyang audible tone as the AOA increases to the near point where the aircraft will stall. The stall warning device include an electric switch that open and close a circuit, a warning horn audible in the cockpit. So, dito, meron lang siyang switch. And then, umiilaw kung malapit siya mag-stall or not. So, pwede siyang may ward and award siya ng warning light at iilaw. So, the switch is located near the point of stagnation on the wing leading edge. Also, a small, lightly sprung tub. Yan, nakikita niyo yung tub. Umaangat yan. Okay? Pag mataas na yung angle of attack and then may papasok, makakaramdam na yan ng suction ulit. So, that tub is held down by the air that diverges at the point of stagnation and flows under the wing. So, this hold the switch open so the horn does not sound nor the warning light illuminate. So, as the AOA increased, the point of stagnation moves down. So, the divergent air flows up and over the wings, now pushes the tub upward to close the switch and complete the circuit to the horn or light. Sorry, baliktad. Okay. So, a true AOA indicating system detects the local AOA of the aircraft and displays the information on the cockpit indicator. So it also may be designed to furnish reference information to other systems on high-performance aircraft. So the sensing mechanism and transmitter are usually located on the forward side of the fuselage. It typically contains a heating element. Okay, ulitin natin, meron din siyang heating element to ensure a ice-free operation. So signals are sent from the sensor to the cockpit or computers as required. See, AOA indicators may be calibrated in actual angle degrees, arbitrary units, or percentage of lift, used symbols, or even fast or slow. So dito, pinapakita natin, there are two main types of AOA sensors. Ay, ito pala. Sorry. Nabanggit ko na pala siya. So there are two main types of AOA sensors in common use. So both detect the angular difference between the relative wind and the fuselage, which is used for reference plane. So yung isa gumagamit ng vane, and vane, yung nakikita nyo sa right side, and then yung isa, yung probe. So the slots led to different size of the movable paddles in the chamber of the unit just inside the fuselage skin. So as the AOA varies, the air pressure ported by each of the slots changes and the paddles rotates to neutralize the pressure. So the shaft upon which the paddles rotate connects to a potentiometer wiper. Ito, ulitin natin para maintindihan nyo. So there are two slots in the probe. Kung nakikita nyo sa probe, pumapasok dyan. So the slots lead to a different sides of the movable paddle. So, yan. Meron dito and meron dito. Yan. So as the AOA varies, the pressure ported by each of the slot changes and the paddles rotate to neutralize the pressure. So si shaft upon which the paddles rotate connects to the potentiometer wiper. Ito, gagalaw yan ng up or down. So the same is true of the shaft of the alpha vane. The changing resistance of the potentiometer is used in a balance bridge circuit to signal a motor in the indicator to move the pointer proportional to the AOA. So modern aircraft AOA sensor unit sends output signals to the ADC. So si AOA data is used to create an AOA indication usually on the primary flight display. AOA information can also be integrated with flap and slot position information to better determine the point of stall. So AOA sensors of the type described are subjected to position error since airflow around the alpha vane and slotted probe changes somewhat with airspeed and aircraft attitude. So the errors are small and can be corrected sa ADC. So to incorporate a warning of impending stall, yung mga AOA system signals a stick shaker motor that literally shakes the control column to warn the pilot aircraft approach a stall condition. So ulitin natin yung stick or yung kinakapitan mismo ng piloto, nagsishake yun kung malapit na siya mag-stall. So electrical switches are actuated in the AOA indicator that at various preset. So AOA to active the motor that drives an unbalanced weight ring causing column to shake. Ganun din sa yoke. So regardless of the many existing variations for warning of an impending stall, the AOA system triggers all the stall warnings in high-performance aircraft. Well, if meron pa kayong hindi na gets, i-search nyo yung paano gumana si AOA. Yun lang for today.